In this video, we're going to finish example 7.8.2, where we had joint random variables x and y with density function here. In the previous video, we verified properties 3 and 4. We're working our way backwards, so we did 4 and 3. And in particular, we found the joint CDF was here, so let's recopy that. Down below, we have our joint CDF, capital F of xy is 1 minus 1 over y squared times 1 minus 1 over x. So we're going to go and do properties 2 and 1. So let's go back and look and see what property 2 was. So property 2 in proposition 7.8.1 was the property that if you take the limit as x and y go to infinity, sometimes written as f of infinity comma infinity, you should get 1. So that is easily verified with our rule here for the joint CDF. And so we've got f of infinity infinity, which is the limit as x goes to infinity and as y goes to infinity of our function rule, which is 1 minus 1 over y squared times 1 minus 1 over x. Well, both of these terms here will go to 0 as x and y go to infinity. So I'll get 1 minus 0 times 1 minus 0, which of course is 1. So that property is verified. So we are left with the first property to verify, and that property is the slightly difficult to remember function rule, or rule to calculate the probabilities between x between a and b and y between c and d. And so we want to check this by first principles and then plug it in on this side and make sure we get the same answer. So let's do the probability. Let's verify. It doesn't really matter what we do, but how about we look at the probability that 2 is less than or equal to x is less than or equal to 3. Actually, it doesn't matter since I'm working with continuous, but if I'd had discrete, the inequalities would matter. So let's use the inequalities that actually match the proposition. And 2 is less than y is less than or equal to 4. Let's verify that this is equal to, and using the memory aid from before, it's the outside values, so f of 3, 4, minus sort of the cross values, the inside and the outside. And so f of, if I do small and large, is 2, 4. 2, 4 minus f of large and small is 3 and 2, minus f of 3, 2, and then add the two small values, f of 2, oops, that's inequality sign, 2 and 2, f of 2, 2. This is what we want to verify. So we're going to look on this side, and we're going to calculate this by first principles, which means that we need to integrate our variable x from 2 to 3, and we'll integrate the y from 2 to 4 of the density function, which is sitting here. So 2 over x squared y cubed dy dx. Now this is a rectangle, and we have a factorable function here, and so we can split that root up, and so we'll do that. This is the integral from 2 to 3 of 1 over x squared dx, and this is the integral from 2 to 4 of 2 over y cubed dy. I left the 2 there because it's going to cancel nicely with the antiderivative that we need here. So this is going to be from 2 to 3, antiderivative is 1 minus 1 over x. Over here, we're going to run from 2 to 4, and the antiderivative is going to be minus 1 over 2, and the 2's are going to cancel, so I'll get 1 over minus y squared. And if we plug these in, so we're going to have on this side minus 1/3 plus 1/2 times on this side minus 1/16 plus 1/4. And so this is going to give me, what is this? 2/6, 3/6, so 1/6 times, and on this side, 4/16 minus 1/16 is 3/16. Simplify a little bit, those 3 will cancel, and I will get 1/32. So our actual probability from first principles is 1/32. Now, if we calculate on the other side, so we want to calculate f of 3/4 minus f of 2/4 minus f of 3/2 and plus f of 2. And I'm going to plug these all into this joint CDF rule up here, and we should hopefully get the same value out. So f of 3/4 is going to be 1 minus 1/16 times 1 minus 1/3, and then minus 1/16 times 1 minus 1/2 minus 1 minus 1/, where am I now? I've lost myself here. So 4, 2 squared is 4, times 1 minus 1/3, and lastly plus 1 minus 1/4 times 1 minus 1/2. Okay, so if we calculate all of these, we're getting 16/16, so 15/16 times 2/3 minus 15/16 times 1/2 minus 3/4 times 2/3 and plus 3/4 times 1/2. So if we go and simplify all of these, the 15 and the 3 will give me 5 here and 2, 8, so 5/8 minus, and this is going to be 15/32. And then these 3's cancel, and I'm left with minus 1/2 and plus 3/8. So 3/8, 5/8, that is going to give me 8/8, which is 1. I'm going to put this over 32 because that's the denominator that I'm going to need. So 32/32 minus 15/32 minus, and 1/2 is 16/32. So I get 32 minus 31/32, which is indeed the same 1/32. So that is the same value, and we have verified all the properties between the two videos, all the properties of proposition 7.8.1, I think. Yes, there it is. Proposition 7.8.1, and we have finished example 7.8.2.